We're going to cover script flow in this video and how things actually work within an LSL script. I'm going to start at the end actually, theory, which is when you click the save button for a new script you've created. If everything you've written is correct, the code will compile and the script will start. Every time you save or restart a script, it recompiles and starts over as if it's running for the very first time. All of the variables are reset to their default value. Everything runs as if it's running for the first time. The same is true of a script you create in inventory and then drag into an object in world. It compiles and runs as soon as it's placed in the object's inventory. So let's start with the very first thing that happens when the script compiles, when it starts. Let's do this by creating a brand new script in world. You can do this on your own land or in a sandbox. Most sandboxes allow you to run scripts. Start by creating a new box on the ground, editing it, opening the Contents tab, and clicking the New Script button. This puts a new script in the object's inventory. If you're within chat range of the box when you created the script, you'll hear it say Hello World in local chat. Congratulations, you just created your first script. I hope you enjoyed the course. Best of luck going forward. Be sure to click the like button and subscribe, and best of luck. Just kidding. While the Hello World script is a great place to start, we can and will do a lot more, obviously. Go ahead and double-click the new script in the object's inventory to open it, and let's review the flow of this script together. Every script in Second Life needs a default state. When the script compiles, this is the initial state the script is running in. Think of a state in LSL the same way you might think of states your body is in throughout the day. You can be in a laying down sleeping state, or standing, or running, or jogging. Think of the default state as the first state you're in at the beginning of the day. You can see the default state begins here and ends here. Everything in between is what runs within the default state. For most of the things you'll do in LSL, you'll probably only need the default state, but it can be helpful in some cases to have multiple states. Inside the default state, you see the state entry event and the touch start event. The indentation is not required, by the way, but makes it much easier to review the code as you'll see going forward. The state entry event will take place every time the default state is entered, or every time you save and recompile the script. Below that is the touch start event, which is triggered every time the object is touched. If you touch the box, you'll see it says Hello World in local chat also. If you look at the first line within the state entry event, you'll notice it looks exactly the same as the first line within the touch start event. Both do exactly the same thing. We'll get a little more into the syntax here in a moment, but this is the default script you're going to start with every time you create a new script in LSL. Note the structure of the code itself. As mentioned, the indentation is not required, but makes it much easier to see where things begin and end. The two events are indented within the default state, and the actions are indented within those events. Also note the use of brackets to notate the beginning and end of states and events. Brackets are used in comparatives and loops as well. Also note the semicolon at the end of the line where the Hello World is executed in local chat. So lines of executed code end in a semicolon, and segments and blocks are designated within brackets. Each state can only have one type of event. So if you wanted to add another new type of touch start event, you would need a new state to run it in. If you have more than one state, you need a link to get to the others. On the other hand, you can do several things with a single touch start event by just using comparatives within the same default state. You'll see how soon. For now, just recognize the structure. Everything within this default state only happens inside of this state. Everything inside the touch event only happens when the object is touched within the default state. Variables and functions can exist outside of states. These are usually placed at the top of the script above the default state. These are where you place universal items that can be referred to by any state anywhere in the script. We'll add some global items here in a minute too. Let's talk about events next. The state entry is an event. It's triggered every time the script is saved or reset. That's because that's when you're entering the default state. If you had a second state in the script and it had a state entry event as well, it would be entered every time you entered that state. And when you went back to the default state, the state entry event there will trigger again. The touch start event below that is triggered every time the object is touched in world. If the script is set to listen for communications, it triggers a listen event when it hears something. If it's scanning for avatars, it triggers a sensor event when it detects one. If it's accepting money, it triggers a money event when it's paid. There are about 40 or 50 different types of events in LSL, each with unique characteristics. Let's just compare the state entry and touch start events for now. Both have the opening and closing brackets like all events do. Both have parentheses after the name of the event. There's nothing in the state entry event parentheses, but there is inside the touch start event. These are the input values that the event accepts. The state entry doesn't need any input values. For the touch start, this represents the number of simultaneous agent touches. Not all events have input values, like the state entry event. Some have multiple input values. You don't always need to use the input values within the event, but you do need to declare them. And since I used the word declare, let's talk about variables a little more next in LSL. As I mentioned prior, variables are just placeholders holding values used in the code. They can and are often updated as the code executes over time. In LSL, variables must be declared or created and classified before they can be used in the code. Where you declare or create the variable matters as well. You can create or declare a new variable within any event. But if you create a variable within an event, it only executes within that event, and it's erased and reset every time the event runs. If you create it and declare it in the global section, however, it can be used and updated anywhere in the code. There are advantages to global variables as well as variables within events. You'll see why soon. Let's talk about the 7 types of variables in LSL. The first and most common type of variable is a string. A string is basically a word or group of words defined between 2 quotation marks. The phrase "hello world" in the default script is a string. Notice it's surrounded by quotation marks. The next type of variable I want to discuss is an integer. An integer is a whole number like 1, 2, 3, or even 400,481. They have no decimal point, which distinguishes them from floats, the next type of variable. Floats do have a decimal value, like 3.785 or 486,000.621. The next type of variable I want to talk about is a list, which is just a group of variables in a sequenced order. You can have a list of names, for example, or a list of numbers, or a mix of different variable types. A list can get bigger or smaller too, as items are added or removed from it while the code executes. Before I get into the last 3 types, note the differences between the variables and especially the interchangeability. For example, there is no mathematical value that can be calculated against the word cat. You can't do multiplication with words, but you could put parentheses around the number 786 and it becomes a word. And if you convert that 786 string back to a number, you can do math with it again. If you convert an integer or whole number to a float or decimal number, you essentially just add the decimal 0 at the end. So the number 786 becomes 786.000. If you convert it back to an integer from a float, you essentially wipe out the decimal point value. So 786.156 just becomes 786. The reason why you declare the type of variable you do doesn't really matter as much when you're first starting out. It does matter as your code starts to get bigger, however. Why not always use a float, for example, and have the advantage of a decimal point? The answer is that a float uses more memory than an integer does when the script runs. And a string uses more memory than both. And a larger or longer string uses even more. When your code is very small, some of this doesn't really matter, but when it gets very big, it can cause problems. It can also cause problems with lists. They get bigger and bigger and consume more and more memory. The next type of variable I want to discuss is a key. Every avatar in Second Life has a unique key, as does every object that's created. The key is the UUID seen in the avatar's profile. Keys can be copied from the edit window of an object as well. The key itself is just a group of characters with dashes in specific places. It can be converted from a key to a string and from a string back to a key again, as long as the characters match an actual valid key in Second Life. The next variable is a vector, which is most commonly used to define location, size, and color in Second Life. A vector has 3 numbers separated by commas and surrounded by the alligator mouths. The 3 numbers represent X, Y, Z in location and size. The first number is basically left or right, or the X coordinate. The next number is in or out, or depth, or the Y coordinate. The last number is the Z coordinate, or up and down. For colors, the first number represents the red value, the second number represents the green value, and the third number represents the blue value. Vectors are used in other ways in LSL too, but these are the most common. The numbers inside the alligator mouths, separated by commas, are actually floats, which can be identified individually as well. For example, if I declare a vector variable for my location, x-coordinate would be mylocation.x. The last type of variable I want to talk about is the rotation. The rotation essentially represents the direction an avatar or object is turned and facing. It's similar to the vector variable, but has 4 numbers instead of just 3. The last number is represented by the letter S, so there's an X, Y, Z, and S in a rotation. Rotations can be converted to Euler or 3-digit vector type variables as well if needed. Rotations and vectors can be multiplied against each other as well if needed. When you're working with poses, it's almost always required in fact. Don't worry, it's not nearly as hard as it sounds. I'm going to discuss functions in the next video. I'll talk more about comparatives, loops, and flow in the next video too. If you're still feeling a little shaky, hang in there. If you understand, even only conceptually, what's been going on so far, you're doing great. Even if you don't remember everything, you're still doing great. Again, feel free to ask questions in the comments section or email me in the address in the description. I'm glad to help if I can. If you enjoyed the video, please make sure you click the like button and consider subscribing. See you in the next video.